Hey everyone, thank you for joining. My name is Jenny Bien. Welcome to today's webinar presented by CII's Upstream, Midstream, and Mining Sector Committee. Please familiarize yourselves with the little question box there on the control panel. You can use this to ask questions during the presentations today. So we have two different presenters. We'll take some time for questions at the end of each presentation, and then if there's still time at the end, we'll do a little Q&A session at the very tail end. So if we don't get to yours, trust me, we'll circle back after with a response from one of the presenters. So thank you for that. Before we begin, I'd like to thank each of you for taking time to join us. I'd also like to thank the leaders from CII's Upstream, Midstream, and Mining Committee for making this happen, for coordinating this today and organizing our presenters. So a big thank you to Rodolfo Gonzalez with Oxy and Dan Farr with PTAG for making this happen. We appreciate everything you do. So today we're going to be talking about strategies to consider for natural gas engines with Mary Savalle. She's a program manager with Radical Combustion Technologies, and that will be followed by a presentation on deploying ESG policies. That's with Mike Matthews. He's the Senior Vice President with Data Gumbo. So with that, I will kick it over to Mary.
Good afternoon.
Thank you.
Hello, everyone. As Jenny introduced, my name is Mary Savalle. I am currently the Field Demonstration Program Manager with Radical Combustion Technologies. But prior to joining RCT, I spent the first 13 years of my career at DTE Energy. If you want to go ahead and go to the next slide. I'll introduce myself a little bit more in a moment, but the agenda for this presentation, it's going to be a lot of content, probably an overwhelming amount as it appears. My goal for this is simply to introduce concepts and provide a real life example of how these concepts came to fruition. But there is a significant amount in each one of these slides, and so I hope that you have time later to kind of go back and absorb some of it because it will feel like a good amount of content. So I'm going to go through a brief introduction, the problem statement, which is probably the key thing to take away from this, and then methodology to solve that problem statement. And like I said, a real life example of how all of this came together and why it is so important to your organizations. And then I'm going to talk a little bit about what investment actually is and why it's so important to me. So as I said, next slide, please. I spent my first 13 years at DTE Energy. I'm a mechanical engineer by education. I'm currently in my master's program at the University of Wisconsin for an engine design. And so my whole world revolves around engines. And so that probably will come across in this presentation where the strategy is probably way more applicable to other assets. My experience is directly with engines itself. And so I put this in all of the classes that I teach, and I believe it with all of my heart, and that is that internal combustion engines are the heart of the oil and gas industry because they truly do provide the power to pump these vital products across pipelines throughout North America. So with that, let's go through what the problem statement is. What are we trying to solve here collectively? Well, as pipelines across North America, not only pipelines, but anywhere where there is horsepower, we are getting faced with stricter regulations. And there are companies out there that are being forced right now to make very critical business decisions. And so with this aging infrastructure and this growing legacy fleet, we have to ask ourselves, do these assets need to be replaced? And is that truly the question that we should be answering? So the next, I would say the way to answer this question is really through a systematic approach, right? So oftentimes we hear, well, this happens, or this unit, we have to try 15 times to start it, or this is just a problem, it's a lemon. And we don't really back that up sometimes with real factual data and a systematic approach to looking at that data to make these decisions. And it's my belief that with a solid asset reliability framework and commitment to invest into not only these assets, but into the critical thinking process, then answering this question can become much more simplified. So as companies everywhere begin this evaluation, millions of horsepower, engine horsepower, is going to be considered for replacement. And so that kind of poses a secondary question, right? Where is it all going to come from? Is it all available? When will it become available? And so you kind of start to compound these questions, and it restructures the question to, do these assets really need to be replaced, or with the right program, with the right investment, and with the right mindset, can that life cycle be extended or fulfilled to what it was originally intended to be? So the way to solve these problems is, in my mind, to go back in history to really gain a foundational understanding of what these assets were meant to do and what the challenges were posed to them when they were designed, and really look at that fundamental concept and not try to necessarily replace that concept, but to really open our mindsets to say, how would we have done it differently if posed with the same issues that we are, or the same, I guess, challenges that we are faced with today. And so the biggest takeaway is, man, our world is changing, right? So as we move through answering these questions, we not only have to look to next year, but to 5 years from now, 10 years from now, and how much of a life cycle can we get out of these existing assets in order to create and prepare for that. So we are going to look back in time just a little bit, and I'm going to take you through just a brief history lesson. I'm sure many of you already know this. I'm just a little bit obsessed with the history of engines and horsepower. So I'm going to take you back to the late 1600s, okay, when really, truthfully, the first engine was designed. There were many years, almost 100 years of engine design before James Watt came in the late 1700s. And he really kind of got known for developing the internal combustion engine, well, the steam engine, right? And so in the late 1700s, he defined horsepower, and there was such a critical component about that, because it really took another 100 years almost for anything new to come to the plate. So, you know, there was a lot of design, there was a lot of improvements coming back, and yet nobody really kind of stepped back to that original design and said, how could we improve upon this design? And so in the late 1800s, that's when we got our first, you know, spark ignited 4-stroke engine. And so for the last 125 years, we have built upon that, right? We have created centrifugal engines, we have created high-speed engines, we have separables and integrals. We have engines that you look at the rotary and all different types that we have built upon, but in the end, they still combust the same exact way. And so last year, and this is when I became involved with RCT, enhanced radical ignition was patented. And it doesn't change. It's still the same combustion. It's still the same Otto cycle that was invented 125 years ago, but it's just a different mental reset on how it's capable and what's possible and how that can improve upon the legacy fleet today. So why is James Watt so important? I'm not going to go through this. I do artwork to kind of supplement my class, the classes that I teach. And this tells the story of James Watt, and why it's so important is that he was the one that really is known for it. And what makes him different? And through my studies of what makes him different is that he not only took on every challenge that was posed to him, he was so confident in his findings and his technology and his developments that he came up with a way to market that product as well. And he came up with his own definition of horsepower, of which we still live by today. And so I often look back at James Watt and say, what made him so different from everybody else that he is the one that is known for these calculations and these inventions? And so I kind of tell this story of how before him, there really wasn't there wasn't a horsepower, right? It was really literally horses and pit ponies that did all of this work. And he came in and he, with that mental reset, said, I have to convey what I have done And he came up with an entire methodology to do that. And because of that, he was successful. Okay, so what is this strategy that I'm talking about? The strategy is an asset maintenance foundational model, I would say, a strategy that kind of follows that mentality. And the very first component in that is building your company's computer maintenance management system, or your CMS capabilities, okay? You have to make sure that they're applicable to each different department within your organization, because oftentimes that one size does not fit all when it comes to really unitizing these assets, right? So these systems that I'm talking about are Maximo, SAP, NetSuite, where you go into your system and you put an asset to a location, and it's really how you maintain your assets and also collect the financial charges associated with them. So the next point, after you get all of your assets loaded into this built CMM system, you have to perform a stakeholder analysis. And I'm going to kind of show a visual on what that is briefly, but I want to get your minds thinking of who are your stakeholders? Who needs to be informed on all of these different assets and at what level? So it really ties back into a communication plan on how you intend to maintain your assets. Next, performing criticality analysis. Are all of your assets critical? The chances are they are not. But how do you define that? Is there a methodical approach to how you define criticality of your assets? And from that criticality, how do you define ultimately your investment plan? Next is failure mode effect analysis. If you've never completed one, I promise you it's going to be overwhelming and look very tedious at first. But the truth is that they were developed by the military to identify risk and how risk is associated with your assets. And so I'll show you an example of that you will most likely have to come back and process later, because it is complex, but the entire purpose is to create those countermeasures to those risks to improve your overall trending within your company, your availability, your utilization, and your reliability. The next step is to utilize those capabilities. So I admittedly pulled this list from IBM because I thought it was a fantastic list. So it not only gives you visibility to your assets, but it also gives you visibility to your workflow and automation. It streamlines processes and manages your workforce. But you have to build it properly in order for it to do all of these things. And so when you do your criticality analysis, building up your CMM system with that criticality will help you and assist you in building your work management and investment as well. But some key components that it does help with are knowledge transfer, but compliance and health, safety, and environmental. It's very important for those two concepts as well. So the next part is to develop an investment plan. Use all of this data that you have now collected and develop your capital versus O&M plan, your 1-year investment, 5-year plan, 10-year plan, and see if your life cycles have now been extended and possibly that replacement plan can be built out even further. And then finally, you have to protect the plan. That is very important, right? You can't just build all of this up and then not have some kind of a maintenance around that system as well. And so in the end, you do have to protect the plan. So stakeholder analysis, I'm not going to stay on this very long. It is a systematic gathering of basically this qualitative data. You want to know how much information each one of those people that has a stake in your project or in that asset, you want to know how often they want to be communicated with and how much information they need. And so this list that's here, it's just a suggested list. It's just high level, but really in the end, you have to ask yourself, who are my stakeholders? You know, how much communication do they want? In what form, and how do we convey that message, right? So for instance, I'm not going to send our senior vice president a detailed spreadsheet with thousands of lines of data because it's not relevant, right? But I might send that engineer that I'm working with all of that data on a continual basis and ask them to process it. And so I have to know upfront how those pathways are interconnected. So that stakeholder analysis will ultimately feed into and help you build your communication plans. So next is criticality analysis. this is one that I had built previously for DTE. And so this was specific to horsepower and compressor stations. And so what it is you have to assign your assets a ranking in order to find out what their overall potential risk is to your operation. So in in this particular example, you know, safety and environmental are always essential. You have to have those two. But then those other 8 to 10 categories you build, and you build them applicable to your specific work product. And then, and this is so key, you have to build pre-specification around each one of those categories. So if I just say reliability and I say rank it on a system of 1 to 10, well, and I send that out to 15 people, there, you know, you could be 1 in some categories and 10 in other, because that pre-specification is not there. And so on the left, you see for some of these categories, you rank it a 1 if it's less than this. You put it a 2 when it's this. So when you get into these group meetings, you might have some ambiguity between a 6, a 7, and an 8, but you're not going to have that huge gap between a 1 and a potential 10. And so once you formulate all of this together, it creates a data-based or a fact-based ranking of the criticality of your assets based on all of these categories that you've already agreed upon. And so in the end, it will essentially kind of spit out what assets you should focus on, what assets you should invest in, and probably give a little bit more attention to or complete your FMEAs on. So 2 FMEAs, right? Whew, this is a lot. So there's 2 different ways to do an FMEA. One is you can take an existing asset, so something that's already been, you know, operating, let's say 50, 60, 70 years, and perform an analysis on that. Or if you're lucky, I would say, and you can get to it in the design process, then you have a tendency to eliminate a lot of that risk up front. And so what I've found, this is one analysis that we did on a 10,000 horsepower unit that I'm going to give in the example in just a second. And this was all of the risk associated with that unit. And what we found is that over that 60 years that it had been in operation, there were a lot of Band-Aids, right? There was a lot of things that were kind of put in place to compensate for changes. And so this takes you back to that fundamental approach. What are we doing? What are the risks? What are those functions of those systems? And it gives you a risk-based assessment. And then you have the ability to go back and create countermeasures to those risks. And as you can see in this example, all those red risks can ultimately be countermeasured very easily and reduce the risk significantly on those critical assets. So next, this is an example of just why investment is so important. This was a 10,000 horsepower unit. It was a Cooper Bessemer Z330. I call this particular unit my baby and have for many years. It is a very unique engine. There were only 26 ever made in history, and this is a very unique one in the fact that it is the only one in the world operating with electronic pre-combustion chambers. So the reason we chose this unit for investment, so why did we get to this point, right? And so that is on next slide, if you can. Great. So why did we choose this unit out of all, let's say, 60 units in our fleet? Well, one, after completing that criticality analysis, it was found that this was our most critical asset in our fleet. At the time, it had the highest greenhouse gas leakage out of the compressor packing. There was no real detailed history of overhauls or maintenance. There was some record, but there wasn't any real details behind those. And then finally, the company had gotten to a point where they said, this is going to be our final investment in this unit. If we don't make it better, if we don't make it more reliable, we're going to make a plan to replace it. And so we went in, we planned an overhaul on the engine, an overhaul on the compressor, and we rebuilt the turbocharger for maintenance. But then I went back to the company and I said, why would we do all of this and not do something else to protect that investment? And so we as a team created a business plan to add additional componentry to it to protect the asset after we invested into the maintenance itself. And so we put an upgrade on it. We put electronic pre-combustion, we did an auto balance system, and some additional vibration control system. So what was the result, right? How did this all kind of pan out for us? So at the end, you know, the unit ended up coming back, and the things to highlight here is that that unit, because of combustion instability over the years, it was limited to a very finite operating range. And once we performed this work, we were able to open up this operating range by over 1,100 horsepower. And we were able to do it and get that unit back into a reliable state. And so just simply by opening up that horsepower and getting those reliability values up, the company saved nearly $3.3 million in investment in additional horsepower, because that unit could now live up to what it was intended to do. Fuel usage was reduced. If we go to the next slide, you'll see that emissions were reduced. But even more so, failure prevention. These additional systems, once they were installed, it helped DTE prevent 2 huge failures on this particular asset, simply by catching things that were faulty prior to them causing any major damage. And so the system very quickly paid for itself. It had a very good ROI. We predicted 3 years, and we actually got it back in about 1.5 years in this particular case. So I am going to get to the point where I'm going to wrap up here in the next minute or two, but we have to protect the plan, right? I talked about that. And in the end, if you do all of this work and you put all of this, this time and energy into it, let's say next year you add 15 assets to your business, and you don't go back and reapproach that system again or have some type of an evaluation of that system, then eventually those assets kind of get lost and they put you back into that reactive mode that you may already be starting in. And so this is just an example of one that I had worked on previously, but you go through and you assess your organization and you make sure that all of these different components have some type of an audit system so that they can continue to provide value to your organization. So I'm going to end, you know, with the why and what is investment. So why do I feel that the strategy is important? Well, one, it gives you the ability to make fact-based decisions, right? Huge. You're no longer going off of opinion or word of mouth. You now have all of the data to make these decisions, and it makes it much simpler. You get more accurate forecasting and predictions, capital planning, O&M planning, workload management, but more importantly, you get increased system reliability, and that has so many more trade-off or benefits to it of its own that are almost sometimes not quantifiable, okay? You get a better understanding of your fleet life cycle, you reduce your overall environmental impact, and then finally you get company savings, right? So what is investment? Overall, the high arching fact, right? It is the action or process of investing money for profit or material. I think that's one that we pretty much all know, right? Or number 2 is the act of devoting time, effort, or energy to a particular undertaking with the expectation of a worthwhile result. Also, again, you know, everything that I just talked about kind of relates back to that. But here's the definition that I hold very personal. It's the archaic version, and it is the surrounding of a place or by a force in order to besiege or blockade it. That real life example that I just gave you guys, there's so much more behind it. It took 8 months of planning, 4 months of execution. It failed upon the first time of commissioning. It took an additional 6 months of root cause analysis and additional work. And at the end, when it came time to put it back into service, it took 2 weeks of 7 days a week and 15 people in the engine room. And so sometimes I look at, you know, what we do for a living as a true group effort, right? Mentorship, investment in people, investment in really understanding that asset and not just throwing somebody in blindly. I've been very fortunate to learn from some very incredibly knowledgeable people in my career. And if it weren't for them investing in me, I wouldn't be able to sit here and present to you guys based on my experience. And so that definition to me is truly the definition when it comes to investment in this particular fleet. So to end, my conclusion is that with a solid framework, commitment to invest in a strong critical thinking, I really believe these decisions can become very simplified for your organizations. So, the goal is not to show that history itself needs to be repeated or replaced. It just needs to be understood and improved upon. And, I believe wholeheartedly that the legacy fleet has a part in our industry, and that with the right investment, it would be good. If I'm going to end by just simply saying who is RCT, it was an R&D company for 10 years until it became an operating company last summer, and I was very fortunate to join them. And they've essentially created a technology that has changed the approach to the internal combustion engine, and inherently has the ability to reduce emissions and control combustion stabilization. And so, that's a different topic, but, I joined them because they had all of this mission in their minds, right? How do we keep these engines alive for as long as they were intended to be? And that was quite honestly forever. So if you have any questions, I know that was a lot of content and I went through it quickly, but I'm always here for any follow-up inquiries if you have any. Thank you, guys.
Thank you, Mary. That was fabulous. I do have a question here, but to address everybody, because we did receive this question, we will be sending, the slides will be available if you're interested. We'll post them on the CII website, and we'll also have a follow-up to all those who registered, so you can access the recording as well as the presenter slides. But my question for you, Mary, we have what horsepower range would be an appropriate level to apply this technology?
That's a great question. And it actually isn't about the level of horsepower itself, but more about its functional needs or functional requirements. You could have a 1,000 horsepower engine that it has the ability to do something that nothing else in your fleet can do. And so it's important to understand the functionality more so than the range of horsepower. So, identifying or building that criticality analysis, it isn't going to just take horsepower would be one section, and then critical business usage or requirements would be another category for you to determine what would be applicable.
Okay, wonderful. That is the only question I'm seeing now other than access to the slides. So you guys go ahead and keep those questions coming into the question panel. We'll take them on the tail end after Mike Matthews presents his slide deck here. Mary, thank you so much. We'll see you back on the tail end for the final Q&A.
Thank you, Mary. Thank you, Jenny. As Jenny said in the introductions, Michael Matthews with a company called Gumbo, and I'm going to talk to you a little bit today about ESG and specifically around reporting and or disclosure. And some of the inputs to that are exactly what Mary was just talking about. So I'll do a few minutes of 101 on ESG, environmental social governance, if you're not familiar with that. And then I'll talk a little bit about, why is Gumbo talking about ESG? And so we're a company that automates contracts. And so how can you use smart contracts to help with your ESG reporting, and how that connects in through networks. And then finally, some specific examples of ESG reporting, specifically around greenhouse gas emissions type smart contracts that we've implemented. Okay, so ESG, what is it? Next slide, Jenny. So I'll go through the history of this in a bit, but really it's about three different things. In addition to, we're all of our companies are driven by the profit motive. But there's been certainly in the last, let's say, 4 to 5 years, a real push around it's got to be more than just profit. So environmental, social, and governance goes to looking at how does your company perform as a steward of nature and the environment. How does your company operate in your local community? How do you treat your employees? How do you treat your suppliers and customers, and then the communities that you live in? and work in. And then lastly, the governance, right? So how is your leadership? What's the transparency there? What's the oversight to ensure that you're following through with your commitments? So that's what ESG stands for. And there's a large ecosystem that's been, I guess, evolved over the last 15, 20 years. And if you think about where you are in this whole process, really what's shown on this screen on the far left-hand side is called the reporters. That's all of our companies, right? All these operating companies out there. We are the, let's say, the emitters, or the ones that are having to report on what are we doing as it relates to ESG. Then there are companies that help us do that, the software providers that, and Data Gumbo would fit into that help you either collect and report the data. And then there are the independent auditors that come in that are verifying what you're reporting is the transparency behind it, the accuracy behind it, and so forth. And you're seeing a lot of discussion around frameworks. Right now, ESG reporting, it's not fully required yet, like financial reporting for public companies, but it's coming. And the projections are by 2024, 2025, in that time frame, that there will be requirements for reporting ESG related information. And as you get to the right of that, this is where the push is coming, is actually from here what's called like the end users, is really the investors. So the shareholders in your company, private equity firms doing investment, they're all beginning to ask for your ESG related performance. And so to get to that, they're looking at the data that your companies are publishing, and then the analytics firms that are analyzing that, just like they do analysis on your financials, they're beginning to do that on the ESG related reports. Okay, with the next slide. So this hasn't, it's evolved over time. This really, I'd say early, pushes around environmental performance, social and governance really began back in the 90s. But it wasn't really until the 2000s that you began to see some things really begin to push. So I've highlighted some of these. If you're familiar with the space, there's been a lot of consolidation in the last couple of years in the voluntary reporting frameworks. Those I've highlighted in the sort of in the blue there. But what you're seeing now is that the SEC indications are that they are going to come out with mandatory disclosure rules. It's expected that they'll be released by the SEC this year. And it's not going to be, okay, in 2023, you're going to have to begin doing this. It's going to be more than likely 2025, 2024, we're going to begin having certain requirements, and then it'll get progressively more stringent over time. Next slide. So across the top here, so how is ESG measured? And this is what at least every company that we talk to is really struggling with. And there's a lot of industry groups that are coming together to try to define these, and then there's a lot of different reference standards that are beginning to consolidate. So across the top there, you have what's called voluntary reporting frameworks, and these are slowly getting consolidated. And what we're expecting in the US is that more than likely, if you are familiar with IFRS on the accounting standard side, that body has formed the ISSB for sustainability standards. And it's expected that that's going to be the framework that's going to be referenced for ESG reporting standards. And figuring into that is the GRI that you see here, the SASB, the Value Reporting Foundation. Those are all frameworks that are going to be incorporated into what we're eventually going to have to report on. And then there are companies, you see, like Amazon and others making commitments to getting to net zero by a certain time frame, and these are ways to sign up for that. The mandatory regulations, as I said, are coming. They're not there yet. And then you've got the ESG ratings agencies that, similar to financial ratings, they're doing that for your ESG reporting. Okay, so this is the reference I made. You kind of look at this both directions. There was, in terms of the voluntary disclosure standards, SASB is one that we at Data Gumbo started with. That's now combined with the IRC into the Value Reporting Foundation, and then that just got they just came out earlier this year that's combined with GRI to report for the International Sustainability Board, right? The ISSB. So it's going to be really similar to IFRS on the financial reporting side, but it's going to be for sustainability standards. So what is the market looking for in ESG reporting? And in one word, it's transparency. You may have heard the term used called greenwashing. And essentially that's, where it's almost vacant commitments out there. There's nothing behind it. The data is not verifiable or auditable. So what these reporting standards are working towards, and companies are trying to define, and then the investors are seeking in the market, is that what you're reporting in terms specifically around your greenhouse gas emissions and other things is that it's measurable, it's verifiable, it's accurate, and you can form essentially a baseline of where you are and then prove your progress towards whatever that commitment is. So if you said you're going to be net zero by 2035, how do you know that? So what's your baseline today? How are you making progress towards that? What changes are you making? So it's all about transparency. Thank you. Okay, next slide. You can go ahead one more. There we go. Okay, so why is Data Gumbo is it's a startup company, and what we do is we automate contracts for industry, and we do that using data and specific data. So the underpinning technology is related to, beginning on the left-hand side of this screen, is have an IoT platform that pulls in data from all kinds of sources. So just like Mary talked about in terms of the performance of engines or compressors, things like that, we actually pull the the SCADA data or the meter data, whatever is available from different sources. That data comes in through that IoT platform, and then a smart contract, it can perform financial transactions, but it could also do ESG calculations. So as it relates to greenhouse gas emissions, if we know the particular engine, we know the fuel consumption, we know the timestamps, we're able to do those calculations and report those automatically. And then the third part of the technology of the platform is really a blockchain. And what a blockchain is in this context, it's a single source of truth. It's an immutable place to store all of that information. So all of that incoming data, the calculations, the reference standards that were used to make those calculations, and the results can get stored into blocks on a blockchain. And that is an immutable storage. And in our context, it's private, it's permissioned. There's no tokens, there's no mining, there's no cryptocurrency. It's simply a single source of truth that is able to take all that data and then show it in blocks. And so what we're finding is we started on the transaction side, and here's an example of that in, let's say, chemical delivery for upstream operations, so for production chemicals. So we looked at, okay, we want to confirm the amount that's been delivered, when it was delivered, what was delivered, and apply the appropriate commercial conditions to that. And we're able to generate the blocks to do that, and then push that information to the financial systems. Well, what we found was we're collecting a lot of the same operational data that could make the greenhouse gas emissions calculations for those same deliveries, as well as the emissions associated with the various chemicals. And so if you were to have, let's say, the timestamp, the distance driven, the type of vehicle that's delivering the chemicals, you're able to make essentially an emissions report for every one of those deliveries and do it in an automated way, and in a way that is accurate because you're able to verify the data sources. It's transparent and auditable. Next slide. So when we're doing the transaction side, it really is, we're not, the smart contract does not replace the current financial systems. We're not replacing existing legal contracts between companies. We're simply automating the transactions, right? So in this context, on the invoicing side, what the smart contract does, it uses that IoT platform and it's looking for trigger events. So it needs to know, the smart contract needs to know that something has happened, something's been delivered. So what is that trigger event? And then it's looking for the verification data or the input data to make whatever the calculations are. And in this case, it's line items on an invoice. So it's looking for the timestamps, it's looking for the volumes, it applies the appropriate pricing to that. If there's a two-way match, so maybe we're getting the truck ticket data from the delivery company that delivered the diesel fuel, we're also getting the flow data or the tank level data from the meter there. And we match those, and if they're within a certain tolerance, you're able to apply the calculation, say, hey, that is a valid transaction. and the result can be pushed out like this as a PDF file or integrated into the financial system, whatever's necessary. But the real power, and this is where we are as a company right now, is in actually the network effect. And so as we get more and more companies onto the platform, automating their contracts with the buyers and the sellers, the network is beginning to get built out. And in this context of what you're looking at here, each of these lines, the companies are connected through smart contracts. So they're performing these various transactions between each company. We're collecting the various data required to, one, do the trigger event, two, verify that the service or the delivery has been made, and apply the appropriate commercial terms. We're also able to use that same data to do, and most of our experience is in the greenhouse gas emissions, be able to do the calculations of not just scope 1, if you're familiar with that, but also scope 2 and scope 3 emissions, because you have this network and you're able to go upstream and downstream of your own operations. So what does that look like? And this really gets to a bit about what Mary was talking about in the full value chain of a process. So beginning with production, and then we're getting into the midstream, what Mary was talking about in terms of the transport of that product. And in this case, I've got a liquefaction example, getting it shipped to a regas plant and then using that to generate electricity at the end. If you're able to have this network and have all of the companies involved in this particular value chain, yes, you can automate the commercial transactions between those entities, between the buyers and sellers as the product moves through the value chain, but you're also able to do the ESG reporting. So if you want to say over here on the right-hand side, and you've seen Cheniere do this recently, that they've made an LNG shipment that is quote unquote net zero. Well, how do you verify that? How do you prove that? How do you go all the way back to the production and know what the carbon footprint is and what are those offsets in a way that is verifiable, auditable, transparent? Next slide. So let's get to ESG kind of smart contracts specifically. This is one of the voluntary standard frameworks. It was originally developed by SASB. They merged with the Value Reporting Foundation, and it's going to be one of the primary inputs into ISSB. If you're familiar with SASB, what they've done is they've gone across about 74 different industry verticals and adapted this framework to the specifics of each of those industries. And so if you are in the oil and gas sector, there's a SASB standard for midstream, for upstream, for downstream, as well for oil field service companies. And the framework you see here is the upper left there is the environmental piece of it, with the greenhouse gas emissions and air quality being two of the primary ones. Then on the S side, you see the social capital and the human capital. So we've actually are working on some smart contracts in the mining sector, where you're looking at, you want to be able to prove that the material or the cobalt that was mined that went into this battery that goes into this electric vehicle was mined in safe ways, to not use child labor, and what are those certificates of that as the product moves through the value chain. And then business model and innovation, leadership and governance, that's the governance piece. Now you're fine, perfect timing. Okay, so I'm going to dive into greenhouse gas protocol, and it's primarily because it's got that's where the data exists for the most part. It's very clean. Once you're able to get the data, it can make the calculations and do the references. So if you're not familiar with the greenhouse gas protocol, you've probably mentioned it a little bit, but it's got really 3 scopes. The first scope is the emissions associated directly with your own operations. Scope 2 are the emissions associated with the power that you consume or purchase to perform your operations. So if you're buying electricity at a compressor station, then the electricity that you purchased, what are the emissions associated with that? So you need to know the power generation source and the locality and things like that, and there's ways to calculate that. And then scope 3, there's upstream, which is really the emissions associated with your supply chain. So all the products and service providers that go into what you do. what are the emissions associated with their operations, and then downstream is the delivery of your product to the market and the emissions associated with that. Most companies are really focused on scope 1 and getting to scope 2. We just did a midstream one for scope 2. And essentially the reports begin to look like this, just like you're able to, since we're collecting the data at that transaction level. So for each delivery of fuel or each delivery of a service, we're able to identify the specific vehicle, the timestamps, have the GPS data, and are able to make the greenhouse gas emissions calculations and produce an emission report. So what you see here on the left-hand side is what's called scope 1 emissions. So this is for fracking operations, and so the diesel consumption during those operations, and we're able to calculate for all of the diesel consumed the amount of emissions that were produced for that based on the GRI standards and EPA. And then on the right-hand side at the bottom there, you see a scope 3 emissions. So these are your contractors or subcontractors. In this context, this is for some offshore operations. So we've got the helicopter that's taking personnel to the platform offshore. What are the emissions associated with each of those trips? Delivery of tools and parts and products to the operations offshore. So what's that ship cost and the emissions associated with that? Again, it's all about the data. So if we can get to the specific data, this is really how the platform works. It's got the different types of data over here on the left, and you could do it across your entire carbon footprint. So just like Mary was talking about in terms of your asset investment prioritization, where you've done that survey of all of your assets, apply a lens of the CO2 emissions, the carbon emissions associated with that, and you apply the prioritization. Where's our biggest carbon footprint? Let's start there at getting accurate measurement and reporting on those, and then begin to move through your whole network. Next slide. And it would look something like this. So it's just as you prioritize that, just like you would do the investment prioritization, you're doing your CO2 prioritization, you could lay out a roadmap over there to the right, and then set your plan that would be realistic in terms of how you're going to get to net zero. Next slide. We're just about done. And this is the wrap here. So this is really where at least the companies that we're working with are trying to get to. Again, on the left-hand side of this, these were the two things come together. This is the emission side. So from your operations, from your vendors and suppliers, you need to get a handle on what is your current emissions, greenhouse gas emissions today. That's that baseline. So just like that asset investment prioritization, you're looking at what is that baseline today. But then, Mary talked about that overhaul that they did of that particular engine, reduce the emissions from the baseline. So that would count as a greenhouse gas reduction. You need to be able to prove that, okay, we made that investment and here's the reduction in those emissions. But that's not going to get them to net zero. So on the right side of this, you see carbon offsets coming. But those have to be accurate as well. They have to be, there's additionality requirements, exclusivity, and permanence. And so we're finding that where the blockchain comes in and the smart contract, you're able to collect the necessary data in a transparent way, make calculations done in a consistent way, in an automated way that can be audited by third parties. And with that, that's how smart contracts, or we're seeing smart contracts evolve into being used for ESG reporting.
Thank you, Mike. We do have some questions for you, sir. Okay, as part of the data, what are the critical field devices that need to be audited and on what frequency?
Yeah, that's a very good question. And so what we do at Data Gumbo, we're not that data field device provider. We do have partners that we work with on that, but obviously it comes down to if it's in the transaction space or if it's in the ESG space, it's got to be whatever the parties agree to, right? So we don't have any specifics that we recommend in terms of the checking of the devices and the auditing of those. It would be up to the counterparties to do that. And what we found is it really is just within your normal maintenance and operations activities that is sufficient to provide accurate data.
Okay, wonderful. Another question, what kind of maturity is necessary from a company to implement ESG reporting? And what would you recommend for a small company to do today to prepare for the future? It's a two-part question.
Yeah, that's also a very good question. And I think I'm not sure if it's really maturity. It depends on where you are in the marketplace. What we're seeing, because it's not yet mandatory, and maybe you're a private company and not public, and so there's not going to be the regulatory requirements for you to do it, but more than likely there's going to be the market pressure to do it. We're already seeing that with some of the large E&P companies or oil and gas companies requiring their entire supply chains to have ESG reporting. So I think it's going to almost be compelled prior to it being required if you are working with companies that are concerned about it. From a maturity perspective, it's really about getting the data and to be able to set an overall strategy for how are we going to accomplish it, because it is a big elephant. It's got to be done one bite at a time, and it's not going to happen overnight. So you've got to set a strategy, stick to it, and it's not going to be months, over years you're going to get to the point where you're able to automate that over time. And what's the second part of the question?
The second part was, let me pull it up so I have it exactly here. What would you recommend for a small company to do today to prepare for the future?
Really not different from that answer is to look at it from a strategic point of view, and it gets back to the data. So if I don't, depends on the business, but if it's asset intensive, it's actually stepping back, just like you would do maybe a vendor analysis on your supply chain. Do the same thing for your emissions, right? So where's your emissions footprint, and then prioritize those, and then begin to identify where's the data going to come from, how are we going to get that data, how can we do this without tying up a lot of resources in the organization, and leverage technology to make it not such a big investment.
Okay, wonderful. And then I think if we could welcome Mary back, I think we have a question for her now as well. The question is, can you expand on what is entered in Maximo communication system?
Yes. So when you're building your initial base, so it kind of comes in phases, right? And you have to compound it as it goes. But the most critical part is identifying the asset and the location for each individual asset and making sure that those capabilities are built around those particular assets, right? So your electrical division of your company, let's say you're a utility, right? The functionalities of Maximo on the electrical side maybe look very different from the natural gas side or the midstream side. And so you really have to build up those capabilities based on what's offered to you. For horsepower, we made sure that, like I said, if there was a compressor station, that was its overarching location. And then each asset within that location had its own particular identifying number, right? So that any work that was done, any investment that was made to that particular asset was then captured under that particular number. And so if you don't separate those assets, then you have the ability to get false data, right? So if you pull a number and let's say it collects all of the data from a compressor station, you aren't able to naturally get down to that individual asset. But as you build it, you have the ability to put in a criticality, so you can feed your criticality into it. You can build your risk into it as well. So it's really working with your distributor from Maximo to understand what functionalities you have and how you can build upon it.
Thank you. Okay, that appears to be our last question today. I think we will return everybody back to their projects 5 minutes early today. We thank you for your time and your interest. A very sincere thank you to our presenters today, both Mary and Mike. Valuable content. This will be available later this week on the CII website, and we will have the slides as well as the recording available for you all very soon. Thank you all. Have a wonderful week. We appreciate your time.
Thank you, guys.